We are the cITIcar team from the Institut für Technik und Informatik at the Technische Hochschule Mittelhessen. Our team took part in the CaroloCup basic event in 2020, and now after a break we are back at the CaroloCup 2022. Our core team currently consists of 9 members, stemming from a variety of different subjects. The competences of our team range from content production, over 3D modeling and printing, software engineering, deep learning, down to embedded programming. During our break, we thoroughly analyzed the results of our participation in 2020 and used the insights we gained to completely redesign our car. Basically, other than the tires, nearly the entire vehicle has been developed by ourselves. Even the tools for our continuous integration are largely custom built. This starts with our own construction of a bus sniffer, continues with the full integration of a version management system into the workflow of the team, and ends with a completely remote controllable test station of the car. Just like last time, our goal is not only to maximize points, but to develop a clean and stable self-driving car. Due to our space constraints, we were not able to build a full track. Instead, we opted to separate important parts like crossings and parking spots into small chunks that we can rearrange as needed and on which we can then test independently. The current setup consists mainly of a simple loop to test basic driving functionality, as well as 2 crossings for checking our stop behavior. Unfortunately, the current corona situation, as well as the chip shortage, caused very heavy delays for our low-level and hardware teams. The following scenes show our first improvised prototype of the car. Since it has severe problems with both its steering mechanism and low-level software, we were forced to control the car remotely. To still gain value from this basic prototype, we recorded the internal communication of our software components and replayed them on our test system to detect possible issues that would otherwise be hidden behind our hardware's issues. Here, the output of the neural net on the inputs of the real camera is shown. As we can see, the street segmentation map is sufficient to generate a path the car should be able to follow. For further testing, we have to generate our sensor inputs from our simulated environment. Here we created a copy of the car as well as a full track in which we can test the complete system. For the parking discipline, the car is limited to 3 meters per second. At this speed, it is easily able to reliably follow the track. After detecting a start line, it will slow down to search for a suitable parking space and then finally park. This high speed is possible due to our new regulation system, which not only regulates its position in a reactive way, but additionally plans the path in advance and even tracks the car in between the camera frames. The overtake mode also works in this simulation. If an impending collision is detected, the path planning switches lanes and the steering regulation corrects its position accordingly. Waiting at stop lines is also not a problem, and we are able to not only stop, but wait to give way to incoming traffic as well. For the 4th task, we picked the traffic sign recognition from the Maßstab. To implement this feature, we would start by mentioning it in one of our weekly virtual meetings. By creating a new scene in our simulation, we can visualize the problem for everyone and also test the solution in our simulated scene later. We will discuss the requirements and select the parts in our project that we will have to adjust. After analyzing the exact requirements and persisting them, we start by discussing possible solutions. When we find a good theoretical solution, we continue by adding issues to the corresponding repositories in our GitLab instance. First, a team member will create a new branch in a merge request to keep the codebase clean. After the solution works without any problems in the simulation, it is time to test it on the real car. When now the real car behaves as expected, the changes will be merged and the issue will be closed.